First speaker today is Dieks, and he's going to read a paper on the passage of time and explanation.
Thank you very much. No, I'm not really going. I'm not going to read the paper. Present the paper. But first of all, I would like to thank the organizers for organizing this conference in USM and congratulate the Van Leer Foundation with participating in the organization of this fantastic conference. I will address the problem of the passage of time, the notion of becoming from a physics point of view. And in order to remind you of that, I've put here the portraits of Einstein and Minkowski, who will be watching over us during this presentation. My motivation is the following. If you look at the literature about time, the A theory, the B theory, perhaps I should briefly remind you of what these theories say. The A theory says that time is characterized by a privileged instant, privileged moment, the now, that moves through the universe. And then opinions diverge whether this moving means that the moving moment is the only one that's real, or that there is some other quality associated to this now. But the essential point is that there is something moving, a preferred point that's moving. The B theory, by contrast, says that the universe is there as it is in its totality, in its entirety. Past, present and future are there on a par. And now if you look at the literature concerning this, I have here two quotes from the Stanford Encyclopedia of Philosophy. You see that one problem people have with this B theory, that's a tenseless theory, is that they say that this theory cannot explain our feeling of motion. We all have this intuition that time is moving and that we are dragged along by this flow of time. And it's a big challenge, people say, for the B theory to explain this. So the first quotation says this: now one very serious challenge to the tenseless theorist, that's the B theorist, is to explain why, if time does not pass in reality, and that's the essential thing of the B theory, there is no preferred moment in time, it appears to do so. What, in tenseless terms, is the basis for our experience as of the passage of time? And then it goes on, even if the tenseless theorist can discharge this obligation, so even if he can come up with an explanation, there is this suspicion that the A theorist can do better. Now, to give away already now the conclusion of my talk, I will argue that the situation is completely opposite to what's suggested here, that the B theorist can explain this feeling of the passage of time, whereas the A theorist is at a loss to do so. In order to reach that conclusion, I have certain steps to go through. First, I will explain, because I assume that not everyone is a physicist here, in a way that's as accessible as possible, what relativity theory tells us about time. And I will explain a little bit about relativity theory itself. Then I will say some things about how our perception of time relates to the physics. That, of course, is the important thing, because this is all about intuitions we have. And it would be very nice if we could say something about these intuitions on the basis of the physics. And I will argue in that second step that physics and the tenseless theory of time actually are in a very good position to handle our intuitions and to explain them. And then I will look at what the A theory can add to that, whether it can do better or not. And I already told you about my conclusion. So first, about relativity theory. Well, according to relativity theory, everything that happens in the world, in past, present and future, can be represented in one big diagram. That's the four-dimensional manifold that I mentioned here. It's four-dimensional because it has time in addition to the three spatial dimensions. So every point, every event in this manifold is characterized by four numbers, for three positions, according to the axis you adopt, and one time coordinate. So these are the spatial temporal locations of the events. And then that's an important thing. There's a certain structure in this four-dimensional manifold. It has a geometrical structure. Between any 2 points there's a distance, just as you have a distance in the plane. Think of Euclidean geometry. Actually, special relativity theory is just a kind of Euclidean geometry. There are some little changes, but you can think of this Minkowski space-time as a kind of generalization of the flat space of Euclid. And then there are laws that operate in this four-dimensional arena. And very important is that these laws operate per point. As they say in physics, the laws are local. And that means that if you are at a certain event in the history of the universe, you will only be able to feel the things that are immediately there at that same event. And of course, things that have propagated from the past can reach you there, but what you immediately feel is what's there at this event itself. And that's really the background for this privileged position of points in the whole setup. It has to do with the dynamics. So it's not just something arbitrary, that the whole universe is seen as a collection of points. It has a basis in the laws of physics. Well, and then there are all kinds of things that are not so important for us now. You can describe the motion of particles by means of this distance function. Actually, they follow geodesics. That means a kind of, well, it's not really short. It's a kind of straight line in the metric, in the distance. And light follows null geodesics. It goes along the light cone. Here I have a little picture of this Minkowski spacetime, this four-dimensional manifold. As I said before, everything is there. We, in 2011 in Jerusalem, Napoleon, this line here represents his whole life. He moves about a little bit in Europe. And so that, that means that the x-coordinate is not constant, and it goes on in time. Sorry?
You were also here, though maybe not in Jerusalem.
Yes. So Aristotle is somewhere there in between, in the 4th century BC, and there I have 2 points, and there is this interval that exists between them. And as you see, there's no now in it. The future is there because it goes on after 2011, and the past is there also in its entirety. Now, what about time? So we used to think about time as something that's universal and that shifts through the universe. But that's not the way relativity theory speaks about time. The only sensible, physically meaningful way relativity theory introduces time in this four-dimensional manifold is by means of this formula I have here. It's a time calculated over a piece of world line. So you remember this world line of Napoleon that I had in the previous slide. If I take a little bit of that, I can integrate this distance function, and that has the physical meaning of time. Now, it's very important that this time is sufficient for all the physics that you do. And it's a time per world line. So there's no universal time and a flow of it in which you take part in this picture. It's a time for each moving system itself. And this is the time that goes into the laws of physics and determines the outcomes of experiments and whatever goes on. It's important for the evolution of physical processes. Well, these are some illustrations. This is in Minkowski. So many of these ideas go back to Minkowski in a famous lecture from 1908. And these are drawings Minkowski himself made, so in his own hand. And you see here, well, this hyperbola with the formula up there. It's like a circle in the Euclidean plane, because it's a collection of points that has a fixed distance with respect to the origin. But this is not very enlightening. It's just a curiosity. I have some other pictures which illustrate the things I've said a moment ago. Here I have a piece of world line again. I have 2 points on it, and this formula here, this integral over the distance function, has the meaning of the time, that's the duration between the 2 events. And this is a light ray. This cone here represents the points that have 0 distance with respect to the apex, the vertex here. So that in a nutshell is the structure of relativity theory. And now there's a very important point I would like to make clear. Take any point in this 4-dimensional manifold. I've taken over this picture from some site on the internet, and there this point is called now. But forget about this. It's just a point. And now from this point, there are other points that can be reached by world lines, and they are all inside this light cone. They're called time-like world lines. And there are other points which lie outside of this light cone structure. And the important thing is they cannot be reached by causal signals. So everything that happens there cannot influence this point in the center here. And the background of that is that there is a maximal velocity of signals. The maximum speed, the signal speed, is given by the velocity of light. And all these points here are just too far away to be reached by signals. So the signals would have to be faster than light. So there are many points for each of us sitting here in this room, many events, I should say, because this is all 4-dimensional, that cannot be reached. And that proves to be very important for the discussion of the now, as I will explain.
The future points can influence now?
Well, I would say that the now can influence future points, but whether or not there is action back in time, that's what you ask.
Don't influence.
So the important thing is that the space-like points cannot be in causal contact with this point. And I don't want to enter into a discussion whether time reversal or something like that, or action back is possible. That's an interesting discussion itself, but the standard view, of course, is that causal influences go from the past to the future. So they go like this and like that. But there have been proposals that it can also be the other way. Yeah, but that's a little bit outside of what I'm saying now. Now, what I already told you is that there is one thing that's conspicuously missing here, and that's the, if you think intuitively about time, and that's the now, which you think moves up. You very often find in the literature that the reason that there's no preferred now is that, well, it just doesn't occur in the Minkowski diagram. But I think that's not a very good reason, because any picture that you draw in which the past and the future are represented will miss this now. It will lay out, every picture that depicts the history of the universe can do without any now. The important point, so that's not a good reason, but the important point, as I will argue further a bit later on, the important point is that any introduction of a now in this picture will prove to be superfluous from an explanatory point of view. It will not do any work in the laws of physics, and it will not explain anything. And that will be part of my project to explain that to you. But before doing that, I should point out that there is some becoming or flow in this picture, namely in a very simple, sober sense. The events in this picture are ordered in time. So there is a succession of now, but not in the sense that there is a succession of time, succession of moments, but not in the sense that there is one preferred moment that's flowing there, but in the sense that all these events are there, but they are ordered. So there's an order of time, and in that sense, passage, events occurring after one after another, but there is no preferred point that realizes this flow. Now I should say perhaps some things about this was all special relativity. Perhaps I should say some things about general relativity. I will be brief about that, because actually the difference between special relativity and general relativity is not that big. If intuitively the difference is like this, so I said before that the theory of special relativity can be compared to just Euclidean geometry. You have the flat plane. And now general relativity is the same kind of generalization of that picture as you have in the theory of curved surfaces in ordinary geometry. That goes back to people like Gauss around 1800. So if you consider instead of a sheet of paper that's flat, something that's curved, let's say blanket or something, then that picture gives you the way to think about what happens to Minkowski space if you go over to general relativity. So to take Minkowski space and curve it a little bit, what the consequence of that will be is that the global structure will be different. And you can even cut holes in it, so the topology can become different. But if you look in very small surroundings, then everything will remain the same. Just as is the case if you have a curved surface, very small portions of a curved surface can be approximated by a flat surface, by the tangent plane. And the same applies here. So the space-time of general relativity in a small surrounding a point is exactly, almost exactly, like the space-time of special relativity. And so many of the results that I adduce here in the context of special relativity also apply to the case of general relativity. So there's not, I think for this whole discussion of the flow of time, it doesn't make that much difference whether you're considering special relativity or general relativity. That in itself is also something that's controversial, because some people think there is a big difference here. And I'll explain you what the difference is. It is possible in special relativity to introduce a notion of now. And the way people often usually do that is by taking this picture I showed you before with the light cone structure and drawing a plane here that's exactly symmetrical between the two halves of the cone. And then this symmetrical plane is called the plane of simultaneity. Now, the status of this proposal is controversial. Many people say this is just a choice. It's a conventional choice to call this the now instead of some other plane or hyperplane in space-time. I do not really want to go into that discussion. There's a whole discussion surrounding that. There's a huge literature whether or not the term conventionality applies to the choice of simultaneity. That hinges very much on what you understand by conventional. And I don't want to go into this very philosophical discussion. I want to focus on something that's not controversial, namely that however you define this now in relativity theory, it always consists of points that are in this space-like region of the universe compared to the point I started with. So I started at a certain point. I'm asking myself which points are simultaneous with this given point, and whatever choice I make, I will always end up with points that have space-like separation with respect to the original point. And that means that however, in whatever way I choose this now, it will never, the points that the events that are part of this now, will never be able to influence the point where I started from, where I am. So any global now that can be introduced is irrelevant for what's happening here. And there you already see the explanatorily, well, lack of use, so to speak, of this now. And the same applies to notions of flow. I already made this comparison with general relativity, and going a little bit further on that. If you look at very small parts of general relativistic spacetime, well, I say very small parts, but in practice that means enormous regions, including, for instance, our solar system. It doesn't matter that much how big it is. So in the mathematical treatment, it has to be infinitesimal, but in practice this can be very big. Well, in these regions, the same applies to general relativity. If it is possible to define a now at all, it will consist of points that are without any possibility of interaction with the point I started with. There is no causal connection. So that, in a nutshell, is the structure of relativity theory. And now I'm going to what physics can tell us about time perception. Now, there's an immediate conclusion of what I said a moment ago. If I model an observer by means of a world line, and I'm asking myself, what intuitions and perceptions will this person have at a certain point of his world line, then it follows from what I said before that what's happening at this now is irrelevant for these perceptions and intuitions, because all these events are without any possibility of causal contact. So if we want to explain our time perception, it's no use at looking at the definition of now or asking yourself what's the right definition of the now, because all these definitions are irrelevant for your time perception. Now there's a whole discussion in the philosophy of time about the new features introduced by the general theory of relativity, and well, it would be too difficult to explain all the details there, but there are certain worlds that are possible according to general relativity that allow what they call a foliation in time. That means that you can define the simultaneity relation in such a way that the whole four-dimensional universe falls apart in a stack of three-dimensional spaces bordered by this time. And some people say that this offers new possibilities for flow and for the explanation of our perception of time. But that's not true, because there's these nows that can be introduced in some of these models of general relativity, as I explained before, are without any relevance for the time perception of an observer. So it's not really important for the whole philosophy at least for the explanation of our perception of time, it's not really important whether we live in a universe that can be foliated this way or not. So that's an important thing, that if you want to explain our time perception, it's sufficient to look at local events. And now it doesn't play a role. Yes. Now there's if we go along further on with this project of explaining our time perception, it's very controversial, I think, among people studying time perception, that our perception depends not on one point on our timeline, on our world line, but on what they call a specious moment, a certain interval that has a certain thickness. And our perception in one way or another, so there are many things here that have to be investigated further, so I'm not giving you any definitive answers concerning these things. But in one way or another, our perception is formed by a kind of combination, integration of data that come in, that fill this interval. And now it's an empirical fact, and I think that's very important for our intuitions about the now, that if you are confronted within such a specious presence, so our attention covers this little finite interval, that if you're confronted with content that differs during this specious interval, the response of our brain has the form of a dynamic thing, a motion. And I can illustrate that to you by a number of examples. Do you see the motion here? Yeah. But so this is not a film. It's just one static picture. But This of course is different from position to position. And I suppose, I'm not really an expert here, but I suppose that this idea of motion and dynamism that's connected with looking at it is a consequence of the fact that during this species moment we focus from one point to another, and so that the content of this species moment is different at different positions, and that engenders that produces this idea of that there is something flowing, that there's something going on. But actually, this is a clear example of the fact that that flow that you clearly see does not correspond to a flow in what's presented to you. So there is no flow on the screen here, but the flow is somewhere there. So your brain responds to this kind of stimulus by the feeling of motion. There are many examples of this kind, and I was very much impressed by another one, but I cannot really show it to you in all its details. If you present people with these three pictures in succession and make a loop of it, so first this one, then this one, then this one, which is nothing, and then going back to this one, so there's a loop, then what you will see, well, I have a film of it, but I cannot show it to you here on the in this PowerPoint presentation. At least was too difficult for me. But what you will see is a continuous motion. You will be sitting in the driver's seat here, and you will be driving along this road, and you will see this without any interruption. So that's I think this illustrates a similar point. You're confronted with a succession of different perceptual contents, and under certain circumstances, this will produce in you this feeling of continuous motion and flow. So I think that there are all possibilities here for biology, sense perception research, biology, in the final analysis physics, to explain these things along the lines that I've just mentioned. So of course there's much more research to be done here, but I think it's just a fact that a series of different inputs can it need not be continuous at all. It can have gaps in it, like this. The third of the pictures I showed you on the previous slide, and engender this feeling of continuous motion. Now, summing this up a little bit, so what I've mentioned is that our perception operates with an extended moment, that's this species moment, and in fact there are attempts in evolutionary biology to explain this thickness of the moment. And so there are many arguments here. One is that, well, our brain needs time to operate with input, so that the things from different sides have to be combined. That needs a certain time. There's a certain threshold within which we cannot discern different inputs. And there's also an evolutionary argument saying that, well, we can to some extent be compared with computers, or that try to find their way. There's a lot of information, and now it turns out that a very small part of this information is sufficient to base our expectations on, and for making decisions. And that has to do with the fact that motion in our surroundings usually is very slow, and so we don't need that much information to store. A little piece of our world line is sufficient. So there are already existing, and this is a booming field, this perception research, but there are already advances being made on the road to an explanation of, not only the finite thickness of this species moment, but also the fact that this thickness is not that big. So we can easily have this idea that it's just one moment. If you just ask people what the present is, they will say it's just one instant. And also represented by one point in these space-time pictures. But that is not true. But you can easily imagine that you get the impression on the basis of the fact that the species present is that small. It's not so very thick at all. And as I told you, these differences in perceptual content during this species present may give rise to this idea of flow. And the most important thing of this all is that all these things can be stated without appealing to a flow of time. It can all be placed in this four-dimensional manifold by means of the B theory. There are also other intuitions that can be explained in a similar way. So the idea that we are all part of one big now, also one of the intuitions, that the now is extended, can very easily be understood because we get information during this very small now, which pertains to ourselves, which comes from very far. Light is very fast, and during this species present, information from big distances can reach us, and we do not get any indication that this comes from the past. So we can understand our intuition that the now is extended, but of course the physical description that I'm presenting you here with, and that's at the background of these intuitions, is objectively better than these intuitions themselves. So in physics a distinction is made between the now where I am and the past where all this information comes from. And there's no question that if you argue very accurately and make measurements that are very accurate, the physical picture is better than the intuitive picture. So I think there's no question of what's the best thing. So what is the resulting picture? It's like this. So this is my word line. Here is this species present, during which I have this feeling of moving through time. But in the setup I've tried to explain, so this four-dimensional setup, this species present is there everywhere along the world line. So I've drawn one of them, but they are there everywhere. And so you could think of, well, my existence represented by this world line as one in which at each species present I'm saying, oh, it's now, and I'm moving along. And that holds for all these points. So it's a tenseless picture in which there is no preferred point, but it accommodates and it incorporates all our intuitions. Also the intuition that the now is extended, so I've drawn light rays here, part of the light cone, and that represents our visual present, what we see at each moment. But these same lines are there at every point. And so the picture explains that always we do feel the same things, and we always see the present as being extended, and we always have this feeling of moving through time. So I think we have a fairly complete picture, also in an explanatory sense, of time, and also our intuitions of time. And now, let me now compare this. How much time do I have?
Another.
Oh yeah. Oh, enough. Yes, standard joke, of course. Okay. So let me now compare this with the resources, the additional resources of the A theory. As I explained in the very beginning, A theorists complain about the B theory, and the B theory is what I more or less have explained to you now. The A theorist complains about that because it cannot really accommodate this motion of the now. Well, I've tried to explain that that's not correct to say that the B theory can explain that, but still, so if you remember one of my first slides, the A theorist retorts that the explanation given by the A theory is better and simpler. Now the A theorist has to explain his strategy here, and the first thing he has to do is to make clear what he understands by the flow of the now. And there the problems already start for the A theory, because it's impossible in this, with the resources that I've sketched to you, this four-dimensional relativistic picture, it's impossible to make sense of a point that's moving. In order to have this moving through the four-dimensional picture, you need to introduce some additional time parameter of time dimension. But suppose the A theorist succeeds in that, so there's a problem there, how exactly to explain this notion of the motion of time. But then the second question is, if you succeed, how does it help to explain our intuition, and how do these added notions improve the explanations I already gave you? Now I've looked at recent literature about this metaphysics of time, and it seems that the conclusion that I've drawn from that literature is that there are two ways which are actually equivalent of giving sense to this notion of flow. One is introducing a super time and saying that the motion of the now through the universe, well, that just means that at super time 1 the now is here, and at super time 2 the now is there. But that means, of course, introducing something additional to the physics, namely this super time, and we have to ask ourselves, what's the content of this super time? What does it do? And there's another way of doing the same thing, and that's by the introduction of so-called primitive tense operators, which boils down to the idea that we just introduce the notions of past, present, and future as primitives, and lay down certain rules that stipulate how we can operate with these notions. And an important point, and that's from recent articles by Bedford Scow, is that it turns out that these two approaches are equivalent. That you can explain this one in terms of that one, and that one in terms of this one. So actually what you're doing here is introducing something additional to what's already there in Minkowski space-time, but the additional thing, what's introduced, is exactly the same as this, or is isomorphic to it. It has the same structure, or same structure as introducing this super time. Now all these details are not so very important, because the basic fact, the bottom line is that in order to make sense of this motion of the now, you have to introduce additional things that are not there in the physics. And you can understand immediately that these additional things that do not play any role in the physics cannot play any role in explanations that you give, at least not scientific explanations. So, from the outset, it's almost a matter of logic. It seems impossible that these additions to our picture of time, this introduction of supertime or the introduction of primitive tenses, improves the scientific explanations we already have. Now, the A theorist is aware of this fact, and he comments on that. And so let's look at the kind of replies they give. So what do the A explanations look like? Well, Scow, I just take him because I admire his articles. He's very bright, smart, and intelligent, writing about the metaphysics of time. And I think most of these metaphysicians are very intelligent and bright, but still I think most of what they write is nonsense. So what does he say? He's just an example. He says, well, B theorists, and I count myself as one of the B theorists, say that change is variation in time. I agree with that. So everything I explained to you about the explanation given by physics in this four-dimensional arena about the change, that's change in time. But this time is there in the picture. So it's the succession of events in time. And for instance, Napoleon is at different moments, at different times, and that's, of course, change. That's motion. That's all well represented. But that's not sufficient. What Scow and other atheists want is not motion or change in time, but it's change in super time. So real change, so this is not real change, according to what the scope is saying. Real change is variation in super time. And now we're going to look at the explanations they give, and we come across things like this. So this is what the A theorist, in this case Sko, says. Change is metaphysically necessary. The universe is always different at adjacent points in supertime. That's a principle he proposes in order to explain this feeling of change that we have. And it goes on like this. Change is the engine that pushes the now into the future. And there is an irresistible pressure for the universe to change. But the universe cannot change if the now remains at one time. So this is a kind of explanation for the motion of the now. There is an irresistible pressure for the now to move. And the engine that produces this pressure is change. And the pressure forcing the universe to change then pushes the now into the future. Now, perhaps this is a matter of taste, but I would say this is a kind of explanation that doesn't add much to what we already know. It works with concepts that are not really well defined. It works with all kinds of associations like time. Like pressure, engines, which really are well defined within the four-dimensional picture and within physics itself, but of which the meaning is unclear within this wider supertime picture. So my first comment is that the concepts that are being used here are not part of scientific theories. These explanations that are introduced here introduce, well, what seems to be additional wheels. It's a superstructure that is added to the physical explanation. And of course, by definition, because it's just an addition without any empirical content, there will be no new experimental results. And as far as I can see, the function of these A theory explanations, first of all, is to give a kind of pleasing, to tell a kind of pleasing story that is pleasing to our intuitions. But we have seen that these same intuitions are very often controversial, and it's not clear at all that these intuitions correspond to something that's really there in reality. I showed you these pictures in which there is flow, in which it was clear that there is no flow and motion in the universe itself. So it's a very dangerous undertaking, I would say, to take these intuitions as the basis of a complete metaphysics. So, what is my conclusion? Well, someone like Sko and also the other metaphysicians admit that they're introducing additional structure. And they also admit that this could be held against them, because it seems to be methodology to have theories that use more than what is necessary. But their counter-argument is that these new theories, introducing this additional metaphysical structure, can explain things that other theories cannot. Well, as you have seen, I disagree with it. I think the B theory can explain all these intuitions. And as I already mentioned a moment ago, the intuitions on which the A theory picture is based are not always uncontroversial. So the B theory does without any motion at all, doesn't need any explanation of the motion for theory. And moreover, there is every prospect that they are capable of explaining our intuition of this moving now. And that's my last slide, I hope. Yes? So my conclusion would be that postulating this additional metaphysical structure, so in particular this preferred now that's moving through the universe in the form of processes that are inaccessible to science, and then postulating metaphysical principles like this pressure that forces the now to move, in order to make this picture intuitively acceptable, is very bad methodology if he can explain these intuitions on which this all is based in a different way. So I would like to leave it at that.
Okay, thank you very much, Dennis. I just have maybe two questions, short questions and a minor comment. Just a minor comment and two questions. The minor comment is about the conventionality of simultaneity, which you mentioned at the beginning, yes. Which I just thought that we should just add to what you said, that the discussion in the philosophical literature about time is not only about the conventionality of simultaneity, but also, as you know, from Putnam's argument and so on, about the relativity of simultaneities. And since you didn't mention it, I just wanted to... So Putnam's argument against the A-theory from relativity theory rests on the relativity of simultaneity, and it has nothing to do with the conventionality of simultaneity.
No,
this is just...
That's true, but my argument is that simultaneity is not important at all in this context.
Yeah.
So,
yes, okay. So this is just... and now, a more important issue, I think, I just want to mention two things. First one is about passage, which you just argued that the B theory can explain. I mean, you've done a wonderful job in I think you're doing, I mean, you've taken out from the B theory the most that can be taken out, but I'm not sure that you got to the situation where you really can explain passage. For example, I mean, you said roughly that passage, the counterpart of passage in the B theory is the succession.
Yes, succession as well.
Yes. But succession is not passage. And you've used terms like, you know, I can ask you what makes an event to occur, when it occurs in the B theory. And you need to answer that, because the fact that there is a succession that there is an order of time or succession of points doesn't even begin to explain to me when we say that an event occurs that it occurs. So what we want is a passage in the becoming approach and so on is meant to explain the occurrence, which I think is in the B theory is the challenge to explain. So.
Well, in the B theory, events are just there in the four-dimensional picture. And
but then
so
what makes them to occur?
Well, that they are there. So it's nothing else for an event to occur than to be there. But
you mean that they occur always? They always occur?
Always?
Yes.
No, each event occurs at its own time. So
what makes it to occur? That's the question.
If they have an equal footing, so...
What makes them to occur? So I'm still thinking about it. Sorry.
I'm continuing
yes?
the comment. If they have an equal footing of
yes.
status,
well, they all are at different times, of course, in order with respect to time. So they're not. So you also said they're always there. No, of course, each event is there at its own time. They're not always there. But they're all in this one picture.
So it's not only the succession, the order. There's something else to it. And what needs to be fleshed out in the B?
No, I don't see that there's something else. Well, what's the else?
Well, local experience.
Sorry?
It's a local experience. I mean, for us, it's a local.
So we have this experience. So that was an important feature, I think, of my talk. That there's this succession of events, and you could say, I could go along with that there's no flow there, no becoming relation. But still, you can explain that at each event, suppose that there's a sentient being there, this being has the feeling of flow.
No,
and that occurs everywhere.
This is my second question, but the feeling of flow. This is another issue. But I think what I'm trying to push you towards is something...
So if you want to associate flow with the motion of a now through the universe, I would say that according to the B theory, there is no flow of that kind, and still we have the feeling of flow. And is it the theory that says that, is it that better than the
so
theory?
I have a question about that as well.
Okay.
Just if I may. I just wanted to add about the occurrence. I just wanted to try to convince you to think about the proposal that Nathan had in his talk about the R relations. That maybe what you have in mind is something like that, which has some primitive idea of a temporal relation, which you may add to the B theory, or which you may modify the B theory in a way that would. But I'm just trying to, and in that way, to explain the occurrence. But that's a remark. That's just.
So I don't think I really understand this question about the explanation of occurrence. But I must say that this was only a sketch, and it needs to be fleshed out in many ways. And one of the things that has to be made clear is the difference between space and time, and I think that plays a role in your question. And I think in order to make it clear what that difference is, you have to appeal to the form of the physical laws, in which one of the four dimensions plays a role that's different from the other ones. And one of the things is that explanation functions differently along the time, or prediction functions differently along the time dimension than along the spatial dimensions. That has to do with the form of the laws. So there is a way in which you can explain the occurrence, but perhaps not in the way you mentioned. Just in the sense that if you given one Cauchy surface, then it becomes possible by virtue of the laws of nature to explain what's going on later on. But that's not what you mean.
That's not my question.
That's a tenseless explanation.
My second question is about the feeling.
Maybe go to someone else. Yes, sir.
So,
I have two questions which are of somebody who is ignorant of this field. I didn't quite understand what the difference in your diagrams was between light and time. That was one thing. And the other question, and then the second question is this, that if you have a plane of simultaneity at that point, there's no requirement that that plane be continuous. It could be discrete events, so you could just, you could have one event and then one event and one event, and
Well, the first question. So the difference between light
and time
and time-like curves. So
yes.
I had time-like curves, and these you could think of as representing the motion of things moving slower than light. So you and me walking along are represented by time-like curves. That's just a technical term. And light goes faster than and that fills this cone. And these are
so time-like curves are just light minus something.
It's heavy objects moving.
Okay.
Not going with philosophy. And your second question was
Same
all
question
about the
with
simultaneity.
Why would that
So
be
the usual way of doing this is having a continuous plane. So this is all based on intuition.
But if you're just at one point and you're seeing these things that are simultaneous with you, like you and him, and that are not causally related, then I could say that I'm just seeing different points and just creating.
Yes, that's an interesting proposal. I've never seen it in the literature, but I wouldn't know why not.
Yeah.
But well, it seems reasonable to interpolate between these things that you see.
Well, like you interpolate between your diagram, but there's no reason to think it's really that way.
No, so that would be an interesting proposal.
Yeah.
Barry?
Much of what you said is very plausible. I worry about the dialectical positioning when you accuse the A-theorist of explaining the periods of the flow passage by concepts which are additional to physics, when you yourself, the big part of your explanation was what we find in our own immediate experience, the flow we find in our own experience. Now, I take it that flow isn't the same concept as used in, say, fluid mechanics. It seems like a psychological concept.
Yes.
A phenomenological one.
The flow of experience, you mean? Yes.
So it too is additional to physics, at least current physics. And so you're in a way in the same position as the A-theorists, which you too are relying on concepts which are features which are additional to current physics. So.
No, my idea was that this experience flow can be explained by physics, and in that sense it is part of physics. So it's not, of course, a concept that occurs in basic fundamental physical theory, but that's the same with all biological and sense perception concepts. So I'm suggesting here that there's a kind of reduction relation between the biological level and the physical level, and that in principle there is a connection between things happening in the physics and things happening in our experience.
It's more likely that one day there'll be a connection between basic physics and phenomenal flow than there is between basic physics and pressure in scales.
I wouldn't say so. Why would that be plausible? I don't see any indication here that there is such a flow at all. I mean, in reality.
Yes?
I have two questions. The first one is, if the sensation of flow is only an illusion...
Oh, it's not an illusion, it's there. Okay, sorry.
It's a process created by our mind, given that we're given certain content. Does it also include the direction? Is it also a part of this illusion? And the second question is, if that's a really big, lame question. If the present is not privileged in any way, then how do you account for the fact that when you are in any present moment, you have data from the past stored in your mind, but you don't have any, you can look to the left, to the right, and to the past, but you can't look to the future. Why it's not privileged?
So both questions relate to direction.
Yeah.
And so that's a point I have not touched upon at all in this talk, but I should have perhaps, but given the limited time and so on. But in order to say something about the direction, I would say, well, I can just follow the ordinary accounts, which is in terms of asymmetries having to do with either initial conditions or second law of thermodynamics, things like that. So the only thing I need within this B picture is an asymmetry between the happenings in the past and what's going on in the future. And that would extend also to memory contents and then what's going on in our brains. So in the final B picture, every specious moment along our world line is very vividly there for our awareness. And in each of these moments, the physical situation is just that there is memory of what's went before, and there is no information or very little information of what's coming. And that can be accounted for by the usual physical explanations having to do with the explanation of asymmetries, which is a controversial field in itself. But I think that there is kind of consensus that at least in principle these things can be explained, either by some hypothesis about initial conditions, either or by some other mechanism.
David. I'm sorry.
In your argument, I think you didn't really use the theory of relativity. So in a way, classical physics could have played the same role. And in what sense does it make a difference in your argument?
Well, I agree with you. So all these discussions are always conducted in the context of relativity theory, but you could ask what's really the import of relativity theory. Now, one of the differences with Newtonian theory is that there you could argue that the now or simultaneity is relevant for some of the explanations because infinite velocities are possible. So you can actually realize the now by having signals that go with infinite, like gravitational signals that go with infinite velocity. Even so, I think that it's not really the now that does the explaining there, but it's the signals that enter our brain. And then I agree with you that even in the context of Newtonian physics, there are no indications that we need any flow. So if you look at the theory itself, you can explain everything along the lines I set out here. You can explain everything without invoking a flow. That which, of course, is in opposition to what Newton himself said, that time flows equally and so on. But well, he was in the process of proposing his theory and starting from everyday intuitions. But once the theory is there, and especially so if you look at it from the point of view of relativity theory, I think that even in classical physics there are no indications for flow, and that it's a very, very difficult concept to make sense of.
One last question.
It seems that probably all of us feel that the particular now one single experience. And then in B theory, say, okay, we don't have this. We have all experience all together.
No. You have just one little now. You experience only a little now. Not all together. They're all at different times along your world line.
I'm not sure that I understand the difference. There are many now. 1 minute later I will have a different now experience, and I maybe remember my experience before entering your lecture.
Yes.
So, and you say that in spite of the fact that we kind of feel that now is special, the fact that this physics, the physics explain all this together is really okay. Will it push you to accept many word interpretation where we have the same situation? We all experience one word, and the physics, the elegant physics, tell us that there are many problems.
Oh, well, I have to think about that. So that seems a similar situation, yes. So the many world interpretation can explain that I'm aware of only one world.
It
seems a similar.
Should support many
yes. So that depends on whether there are other interpretations of quantum mechanics that perhaps are more elegant or simpler, and that's a difficult discussion. But I see the analogy, yes, and thank you for pointing that out.
I'd like to thank our speaker. We're ready to go with our next speaker, an organizer, Yuval Dolev. He's going to present a paper entitled, The Cosmic Present, a Necessary Feature of Time Consciousness.
So, I'll close. Yes, this is mine. How do you run this? That's it. So I'm a bit frustrated I didn't hear Dennis's talk before, because much of my paper, much of my talk relates to Dennis's stuff, one of his papers in particular, and I don't want to sound too rude, but I think it's a good thing. I intend to more or less negate everything Dennis said, 98% of it probably. And I would have been more focused on what I want to negate had I heard the talk previously, but I think I'll try to focus on the right points anyway. So I want to start with a little confession, which is that despite all these years that I, like many of those here, have been dealing with time's passage, I still find the notion quite mystifying. But there are several claims that I think I'm prepared to defend without hesitation. So one of them is that time's passage is not an illusion, and I will of course mean something different from what Dennis presented by this notion of time's passage. I'd like to, in response to Dennis's last slide, add in this context that I see no prospect whatsoever for a B-theoretical explanation of either motion or the sense of flow. Two, I think time's passage is not an empirical matter. So our understanding of it will not advance one iota from any kind of lab work or further scientific research. And behind this statement is a more general belief I have, which is that our understanding can go beyond scientific explanations, as important as those are, of course, not to dismiss them. But I don't feel the drive or the need to limit explanations to scientific explanations. And in particular, I think time's flow is an interesting concept, the understanding and analysis of which go beyond what physics has to offer. My third claim is that time's passage does not consist of the moving of anything, of some spotlight from heaven that makes events that become present real. And so I want to stress right now that what I will say, despite going against the B theory, should not in any way be understood as an endorsement of the A theory or presentism or any version of that kind of theory. I think those theories are very bad. in fact. So, and I want to emphasize that because I think it will be easy to confuse what I will try to offer with them. I want to distance myself from them as much as possible, and certainly from the kind of stuff that Dennis brought from people like Sko. Not my cup of tea at all. Okay, 4, I want to insist that time's passage is a truly important notion to grapple with because it has a crucial role in how we experience the most important things in our lives, and also because it is tightly related to death, a notion that came up several times yesterday, but I will skip this time, though I myself enjoy talking about it, at dinners at least. There's just one time, that's another claim I want to make. There aren't A times and B times, there aren't cosmological and conscious times. The cosmological and the conscious are two aspects of one thing which are related in ways worth exploring, and this exploration will be one of the focal points of this paper. And here I think I'll probably say some things that may connect by opposition with things that Professor Mutzkin said in his very brief remarks yesterday. So Dennis more or less set the stage for me in terms of relativity theory, and I won't go into that again. Obviously, relativity theory is a great occasion in which to consider cosmological and conscious time together. And it is a well-known fact that relativity theory challenges the notion of a global present. One thing that relativity theory has done is highlight, and Dennis spoke extensively about this, the experiential inaccessibility of distant places, and therefore perhaps the experiential irrelevance of distant places. So what happens on Andromeda, this is a photograph, not a picture, it's a photograph of the galaxy closest to ours, called Andromeda, which I think is about 2.9 million light years away. What happens there is of absolutely no relevance experientially to us, because anything that happens takes almost 3 million years before signals from that happening reach us. And as I just said, Andromeda is very, very close to us. It's a twin galaxy. In fact, I think Andromeda and the Milky Way are gravitationally connected. Whatever happens beyond Andromeda, which is most of the universe, is even less relevant. So with respect to Andromeda, for example, and I think it has to be 2.9, I'm not sure, there are 2.9 million years of events from which any event can be chosen as present without this choice clashing with either experience or theory. So I suppose and insist that any of them is really present, which is what I want to insist. I will want to insist that a notion of a global present is crucial to us. So I have two aims. One is to argue that a global present is not something we can give up on. I want to say that just as we can meaningfully ask what's happening now in the room next door or in Tokyo or on Mars, so we can ask what's happening now on Andromeda. In fact, we cannot but think of events there as we cannot but think of events there as being either past, present, or future. So in the context of arguing for a global present, I will consider two interrelated theses that are put forth by Dennis Dieks in a paper I like very much. And Dennis put these theses forth as part of his defense of the block universe in which there is no present at all, global or local. So one claim that Dieks makes is that the notion of simultaneity does not bear any experiential significance because everything is local and can not only theoretically but also phenomenologically be relinquished. Once this claim is made, the path is clear to getting rid of tense altogether, theoretically and phenomenologically. And I think this is a very interesting claim because standardly the debate between A and B theorists is about the reality of tense, about whether tense is a property of the things we experience. But there usually is agreement that simultaneity is an objective relationship that obtains between distant events, though it may be, as May pointed out, frame-dependent or frame relative, and that tense is part of how we experience things. So usually there is an agreement that simultaneity figures in experience, and that tense also figures in experience, not as a property of what we experience, but as a feature of how we experience things. So Dieks rejects this widely accepted maxim. Okay, I would also like to note in passing, but I'll do this very briefly, that in this respect, Dieks is not being a good friend of B theorists, because B theorists rely heavily on the notion of simultaneity. I mean, their central notion of tenseless relations relies very heavily on there being simultaneous relationships between distant events. Dieks' second thesis is that the notion of Dieks' second thesis offers his alternative account, which is structured around the notion of becoming. And I think I also mentioned this in passing that Dieks' thesis has quite a bit in common with what Nathan Oaklander presented yesterday under the title The R Theory. According to Dieks, becoming can replace tense and passage in any description we give of our experience and thus of the world. And I will get back to this thesis later, but I think you have a very good idea of what Dieks has in mind because he just presented it. So my first goal will be to argue that we cannot do away with tense or with passage, and by that I will mean, among other things, that we need a global present. And I will claim that the notion of becoming cannot substitute either tense or passage. My second aim, to which I'll turn towards the end of the paper, will be to use the debate concerning distant events to examine the relationship between cosmological and conscious time, or more accurately, between these, as I shall argue, interlaced aspects of time, which is, I think, one thing. To be sure, the reason why tense on Mars or Andromeda is important, if it is important, is not empirical. As I said before, NASA's Spirit, I think this is a picture, not a photo, was not sent to Mars to discover whether time flows there or whether some events there are really present. The question of tense and passage at distant locations is interesting if it is because of what we can learn about the nature of tense and of passage, not because of what we learn about those distant locations. And tense, as I said, I think is very important because of its intimate relationship with emotions. Emotions are tense sensitive, I'll elaborate about this shortly, and tense is given to us solely via the emotional manifestations of tense. Now, this probably makes anybody with any kind of realist leanings feel very uncomfortable and worry that this will be another postmodern psychologistic meditation. But I will want to argue that emotions, and only they, facilitate a realist conception of time as it is independently of our emotions and of our preferences and so on. So that is another point I will argue for. Since emotions are crucial for our understanding of time, they are also crucial for our interpretation of relativity theory. And again, I want to say I'm speaking from a realist viewpoint. So with this conception of tense at hand, what I will want to explore towards the end of the paper are the reasons why, if we give up on tense at a distance, experientially veiled or irrelevant locations, we get into a serious muddle with respect to our understanding of that part of reality which we do experience. So let me turn to my first task. My first claim is that the present, now, is either global or else there is no such thing as the present at all. So either it makes sense to ask what is happening now at X for any location in the universe, or else B theorists are correct, and nowness is not a property of any event. Specifically, I want to claim that the notion of a spatially restricted present makes no sense. Several thinkers have suggested that the present may be limited in space. So here I drew a few circles around the Earth, just to give a little caricature, perhaps, of the spatially restricted present. So the present expands beyond the Earth up to a certain point, but somehow magically stops there. I will mention one or two thinkers that present this view. I don't know that they hold it. So Pooley and Gibson speak about the Stein present, and Savitoys with what he calls the Alexandrov present. And this present is construed like you see in this diagram. First, it's conceived to be temporally extended. It's not a point. And it has a fixed duration, let's say 1 second long, or to connect with Jimenez's talk yesterday, a tenth of a second, and they speculate about why it should be a tenth of a second, and these speculations have to do with the rate at which brain processes occur. So if we take some time-like line in Minkowski space and consider an interval of the standard duration on that line, then following Savitt, we can mark this interval as E0 to E1. The interior of the intersection of the future light cone of E0 and the past light cone of E1 is the Alexandrov present of the interval E0 to E1. This conception of the present has several attractions, but I'm convinced it's untenable. I'll skip the discussion of why I think this conception of the present is ultimately not attractive. One thing that troubles me is, of course, the arbitrariness of the time interval. I don't think we can think of. I think the present is not point-like, but it's not of an arbitrary duration. I think it's of a duration that is sensitive to which present event we're looking at. Another thing that I don't like about this idea is that it suffers from a very curious consequence that was pointed out already with respect to Stein's original proposal of a spatially restricted present, and that's that some future events become past without ever being present. And that's certainly a strange state of affairs. So that would be like trying to imagine someone becoming 50 or becoming 50 without ever being 40 or something like that. So again, I'm skipping this because I don't want to run out of time later. I just want to say I think this is it's an interesting proposal, but not one we can go with. And if we don't go with this proposal, then we're back to the conclusion I was stating before, which is either the present is global or there's no such thing at all. So it's either it spans the entire universe, or there is no such thing as a present. A present that is somewhere between 0 and infinity just doesn't make sense. Okay, so now I want to move on to Dieks' view. If we reject the spatially restricted present, as I think we should, then we, as I said, we have to choose either the present is global or else it's nothing. Now, most B theorists affirm that even though reality is tenseless, experience and language are tensed. Recognizing that language and experience are irremovably tensed is exactly what differentiates new B theorists from their predecessors who strived at the time to find ways to eliminate tense from language or to so-called translate tense into sentences that are tenseless. Thus, the standard position of B theorists is that tense and passage are irremovable illusions. Rarely do we encounter the more daring thesis that tense is not even an illusion, namely that experience is not truly tensed. And that's the kind of position that I think we can find in Dieks' work. And the inspiration there does come from relativity theory, though I think as Dieks clarified when he answered Michael, the same arguments ultimately can be made in the context of classical physics. So first, Dieks makes observations about simultaneity that he didn't, okay, that's another picture of the restricted present, that he didn't go through today, but I'm bringing them from his paper. If we decided to scrap the term simultaneity from our theoretical vocabulary, no problem would arise for doing justice to our observations. This ties in with the fact that relativistic theories can be given completely local formulations. Simultaneity plays no role in the dynamical laws of relativity theory. So if indeed we scrap the term simultaneity from our theoretical vocabulary without doing injustice to our observations, and note that these observations include our own experiences and our own judgments, that now is now, and our own memories and so on. So they include everything that happens locally, including what we usually refer to as the mental. Then we can certainly let go of a hyperplane of simultaneous events which are present, that is, of a global present. And since we have rejected a spatially restricted present, we have thereby given up on a present altogether. So the phenomenological claim is that simultaneity and tense do not figure in either facilitating or analyzing our experiences, or indeed in experience itself. In the language of relativity theory, the contention is that all the infinitely many foliations of the space-time manifold that relativity theory offers, are compatible with our observations and with our experience. Now, once we got rid of simultaneity and tense, Dieks proposes to replace them by an account in which the notion of becoming is crucial. According to Dieks, this notion can do all the work that is required insofar as accounting for experience and for our scientific theories are concerned. So here's another quotation from Dieks. Events come into being by occurring, by happening. What else could their coming into being be? In the block picture, it is recorded for each actual event that and where, when it occurs. Coming into being means the same thing as happening. There is no need to augment this block universe in any way. Becoming is nothing but the happening of events in their temporal order, which is what Dennis presented a little while ago. Now, Dieks' notion of becoming, and I just want to again mention in parentheses that if B theorists are happy about this, they shouldn't be, because I think Dieks takes away from them a crucial component of their theory, and that's the notion of simultaneity. Dieks' notion of becoming is unquestionably attractive. It is simple, parsimonious, and it eliminates at once all the conceptual conundrums given rise to by relativity theory and many of the difficulties we encounter in the metaphysics of time. But its appeal relies on its being corroborated by experience, and Dennis makes a big effort to insist that we can explain experience from within this framework. And I want to look at this a bit more closely. So becoming replaces both simultaneity and tense, and I want to look at each of these in turn and see if it actually does the trick. As pointed out, and given that we're staying away from those Alexandrov presence and those other ideas, the no simultaneity claim must be taken very strictly and apply not only to events on Andromeda and on Mars, and I think this is a point that Dieks doesn't pay enough attention to, but also to those at the tip of my fingers, because I don't think that the scale of distances we're talking about has any relevance in this discussion. So it's much more intuitive to go with very distant locations, places that are located 3 million light years away, but I think the claims made should pertain to events a couple of centimeters away from each other as well. And that seems to me highly problematic, so very, very briefly I just want to say why. Simultaneity, I think, is a constitutive feature of our field of vision. The visual field consists, and even must consist, I would argue, of several simultaneous, thank you, happenings. And this is just a sketch of an argument that needs to be filled in, but I think can be filled in. If the figure-ground distinction is constitutive of the visual field, as I think it is, then so is simultaneity. For the figure and the ground make up the visual field together at the same time. So, for example, this room and its contents are the ground against which the page I'm reading from right now stands out as the figure. Hence, and that's what's written up there, without the notion of simultaneity, the visual field disintegrates, and with it the possibility of doing science, because obviously if we can't experience, we can't do science. And this connects to what I was saying before. I think science presupposes an immense amount of phenomenology, and almost trivially it presupposes that we can see. And the fact that we can see presupposes simultaneity. No scientific theory can be the basis for a claim which, if it were true, would render the generation of that theory impossible. And so I don't believe we can defend the claim that simultaneity has no role in experience, certainly not on scientific grounds. What about becoming replacing tense? So becoming seems to serve B theorists perfectly well. It grants them local simultaneity, and it diffuses any difficulty the conventionality or relativity of simultaneity may give rise to. And it grounds the B-theoretic conception that at each moment t present are those events occurring at t, which is what Dennis was pressing. Yet I think that as a substitute for tense, it fails. Its flaw is that it obliterates the difference between the past and the future, a difference that has a vital role, at least experientially. And I will argue that also in the reality we experience. I don't take the difference between the past and the future to just be something that modifies how we experience. I think it really is in what we experience. So let's look at two events. Last year's time workshop at Wake Forest, some of the participants of which are here, and this present workshop in Jerusalem. This one, the present event, is becoming or coming into being or simply happening, as Dennis puts it, now at its temporal location. And the Wake Forest workshop is happening at its temporal location, and they are not happening at the same time, as was suggested by some of the questions. Each is happening at its own time. That's what becoming comes to. Events come into being by occurring, by happening. But in this description, we've lost something crucial, and that is that this workshop lies at the Wake Forest University's workshop's future. And that workshop is located at this workshop's past. So this is, for me, a very important difference. It's not that each of these events is there as viewed from the other, as is presumably the case with spatially distant events. While spatially, there are different ways of being there. So Wake Forest is there for us just as we're there for them. Temporally, there is all the difference in the world between being there in the past and being there in the future. There is a distinction between one there and another, a distinction that is absent from the spatial analogy. In the black universe, and absent from the black universe, but is experientially, and I don't think anybody would contest that, of monumental importance. Now, there are theoretical ways of accounting for it, but most of them rely on causal accounts, and at least Nathan Oaklander, and I think also Dennis Dieks, do not want to fall back on the notion of causality in order to explain this asymmetry. And at any rate, I don't believe that there are ways of removing this asymmetry or reducing it to something else. In short, becoming, the notion of becoming does clash with an aspect of experience, and remember, it was supposed to be corroborated by experience, which is as ubiquitous as it is irremovable. Pastness and futurity cannot just be peeled off of past and future events. But they are absent from the black universe in which events simply become. So I think that's a major problem with the black universe. So let's take stock of what we've concluded so far. Either either all events are at some point present, or else no event is ever present. The present is either global, or else it comes to naught. The best way to flesh out the latter option is via the notion of becoming, but this notion clashes with experience. If we wish to avoid such a clash, we should maintain the global present. Now, it may well be that with all our will to preserve tense and passage and global present as features of reality, we cannot do that. The A theory, I believe, succumbs under the B theoretic arguments directed at it. And if we have no other way of accounting for the reality of tense, we may have to accept the black universe despite its incommensurability with experience. But there is an alternative to the A theory, I believe so, which is a form of realism about tense and passage, but a very different form from the A theory or from presentism. I believe that we ought to fully embrace the B theoretic arguments against presentism and discard the claim that only what is present is real, or that only what is present exists, which is the main tenet around which A theorists and presentists structure their doctrine. But we must just as vehemently disallow the B theoretic alternative that denies the reality of tense. The flaw underlying both doctrines is the same. It is the thought that tense is an ontological matter, and that the elucidation of tense must come in the form of ontological theses involving ontological comparisons. Presentists or A-theorists think that present events are ontologically superior to those that are not, that only the present is real in some way. B-theorists think all events are ontologically equal, on an ontological par. The problem, however, as I see it, is not with the outcomes of such comparisons, but with the thought that such comparisons uncover the nature of tense. I think we need a different analysis. So I propose to reject both. Presentism is just one way of analyzing the reality of tense and not the way we ought to adopt. My proposal is to remain faithful to the fundamental fact of experience, that some events and experiences are present while others are not, but to relinquish both the ontological fairy tale this truism is couched in by presentists, as well as the B-theoretic myth that the world is a frozen block consisting of unchanging tenseless facts. And here I would also have to comment on the R theory, which does not take the world to be a frozen block, because there's the dynamic aspect of it, but as I asked yesterday, we need an account of the asymmetry between the past and the future, which I think our theorists are obliged to provide. Tense and passage are real as opposed to illusory. They pertain to real events and do not merely reside in our heads. In particular, it is a feature of reality, not merely of our apprehension of reality, that some things are present. But while this involves real differences with things that are not present, the differences have nothing to do with ontological hierarchies, and so nothing to do with only present things being real. So we must separate only what is present is real, which is presentism or A-theory and so on, from there are real differences between being present and being not present. So what's the alternative analysis? What I propose is to replace ontology, understanding the differences between events that are present and those that are not, in terms of ontological differences with phenomenology, and I will very, very, very rapidly run through just a very cursory outline of this. So that the nature of our contact with events entirely depends on their tense locations is uncontestable. With respect to pains, for example, it is quite obvious that only present pains are painful. We are all familiar also with how anxiety is replaced with relief once an ordeal is over, a visit to the dentist or something like that. And this phenomenon is extremely widespread. Almost all our psychological and emotional dispositions towards an event, as well as our practical attitudes as they are expressed in our deliberations and actions, depend on whether the event is present or not. So think of how one psychological state shifts dramatically as a bungee jump becomes present, and again when it becomes past, and Nathan already saw this girl, which I just chose at random from the internet. So here I put into Google, what did I put into Google? Before bungee jump, so this came up. And then she put a picture of herself actually jumping, which I was very impressed to see that after she was crying, she actually did. And then she put up from a completely different occasion, but I put these together, a picture of herself very proud, satisfied, content that she has done it. So her psychological state shifted dramatically with respect to this one event of jumping from a bridge. So that's one manifestation you're all familiar with how our emotions are sensitive to tense. Or think about how one's practical thinking and behavior alters when a business negotiation gets underway and after it is concluded. Being present means being the potential source of a variety of sensations and attitudes that are distinctive of our dealings with present events and cannot be met with in relationship to events that are not present. I want to stress this point, that psychologically, emotionally, you cannot recreate the same sensations with respect to events that are not present as you actually experience with respect to events that are present. The same is true with perception. I want to claim that only the present is experientiable. We cannot experience, for example, perceptually, things that are not present. So here's a guy looking at a lunar eclipse. He's actually seeing it. Here he's remembering it, which is an experience of a completely different flavor, and these cannot be reproduced in inversion. Here he's anticipating a lunar eclipse, which is again another type of experience, and the three are very different. So one thing that typifies present events is that we can actually experience them, and again, psychologically, that's not a sensation we can recreate with respect to events that are not present. So my claim is that these differences are the basis for our understanding of time. The sensitivity of dispositions and attitudes to tense has to be mapped out and described in great detail. And I think a lot of what we heard yesterday was this kind of mapping out of how tense figures in the richness of tense in our lives. But if we're, so it has to be done in great detail. If we're to account for tense, this map is our account. And I think it's an open-ended project. Every thinker contributes his bit to it. Every item uncovered in this kind of phenomenological investigation enhances our grip on the nature of the distinction between the past, present, and future, and thus of time. I want to also add, but I will skip the arguments for this, that the alternative I'm sketching constitutes a form of realism, because it would be very easy to come back at me and say that ultimately I'm just falling back on some version of the A theory. So I don't think I'm doing that. There's nothing mind-dependent about tense and passage as I conceive them, or as I propose to analyze them, even if our grip on tense and passage entirely relies on experience. The key to understanding this claim lies in the following fact about time. There's a unique relationship between time and experience. Time is unique in that experience itself has temporal features. There's nothing red, round, or fast about the experience of seeing a red ball fly across a field. Experience does not have spatial or geometrical or color properties, but the flying of the ball and the experience of seeing it do share temporal properties. Or looking at a lunar eclipse, the lunar eclipse being one event, and the experience of seeing a lunar eclipse, which is another event, have in common their temporal properties. So in this case, they're both happening now. That the presentness of our experience is also the presentness of what we experience puts presentness together with other properties of the experience as something that is, as it were, given to us, and that has nothing to do with our tastes, preferences, and decisions. We learn that a red ball is flying across the field from seeing this event. We learn of the event's presentness from the presentness of our experience, for the event and our experience of it share this presentness. This intimate temporal unity between an experience and the experienced allows us to discern from the temporal features of experience, and specifically from the sensitivity of experience to tense, an understanding of time and tense. The presentness of events is given to us by comparison with the presentness of our own experiences, something I need to elaborate on but won't now, just as the length of an object is given to us by comparison with the length of a standard rod. So the nowness, for example, of this talk is as objective as that of the distance between the Earth and the Moon. Now is not, as is often mistakenly thought, now is not like here, rather now is like meter. Our tense, sensitive, emotional, psychological, and particular and practical attitude should be held not as constituting, not as making up the difference between the past, present, and future, but as rods, as it were, temporal parallels of the Paris meter rod, with which we dip into reality and attain a grasp of its temporal features. The tense relations are like spatial distances, objective, mind-independent. If you wish to revert to this problematic clause, it's problematic because usually we run into trouble when we want to explain dependence, the term dependence. But that there is this analogy should set aside the worries of realists. If you can be a realist about the distance between the Earth and the Moon, then you can be a realist about tense, I argue. Okay. Now I want to go to my second task, and with this phenomenological alternative to presentism, to return to the question of the relationship between the cosmic and psychological aspects of time. I've argued that since the present is either global or nothing, and since we cannot give up on tense with respect to some events, we must accept the globality of tense. And again, let me just make sure we're on the same page here. What I mean is that events are tense, not that our apprehension of them is somehow modified by tense. Tense is not an operator that works on propositions, and it's not an operator that works on our mental states. Tense is a feature of reality. So let me state again two questions that were kind of touched upon at the beginning of my talk. One is what's happening now in Andromeda? And the second question, which for me is more interesting, is why should we care what's happening now in Andromeda? So for one, we saw two answers. One is the tenseless answer, which is that the term now does not apply to Andromeda. And I argued if it doesn't apply to Andromeda, it doesn't apply to the tip of my finger, and it doesn't apply to what I'm saying now either. So either it applies everywhere, it doesn't apply, or applies nowhere. Now, with respect to the second possibility, which I've been advocating, there's a whole range of positions as to which event should be picked, which of the many events that can be picked consistently with physics that are happening now in Andromeda should be picked as the one that's happening now. And that's a huge mess, which, like Dennis, I will skip. Yechiel has a proposal in his dissertation in which he argues that there is a fact of the matter as to which event is happening now in Andromeda, but this fact of the matter is epistemologically inaccessible to us. We cannot know. I do still favor the plane of simultaneity that Dennis showed in one of his slides, though I am aware of many many problems this option gives rise to. But I want to turn to the second question, which I find philosophically more intriguing, and that's why should we care what's happening now on Andromeda, given, again, that whatever happens there can have no bearing on us. So in a sense, we really don't care. I mean, if a volcano is erupting on some planet on Andromeda, we couldn't care less. But I do think we care about it in a different sense that I want to try to flesh out. So let me try to go about this in a slightly roundabout way. How much time do I have?
Not too much.
How much? 3? Good. 4? No. Okay. You're in Israel, Nathan. You're going to run into this in the old city a lot more. So is it important to know that 12 times 12 equals 144 on Andromeda, or that 100 centimeters equal 1 meter there? Do we think that objects on distant stars have masses? Whatever is the case, there is whatever is the case there is of no relevance to us here on Earth. And if some science fiction author claims that weird things happen there, even to arithmetic, we cannot refute him. Still, it seems clear that does not, in the context of a philosophical discussion, license us to say just whatever we want about Andromeda. There are constraints on what can coherently be stated or thought, even about parts of the universe that are in principle out of our experiential reach. So let's explore these constraints a little bit. Alpha Centauri no, I don't have a picture of it, is much closer to us. It's 4.3 light years away. Events that took place there 5 or 10 years ago are relevant to us because signals for those events have reached the Earth. So if, for example, Alpha Centauri, this is again Andromeda, but it doesn't matter, had turned into a lump of marshmallow, we here on Earth would be very interested about that. Now, is it true that if something like that happened only 3 years ago, and therefore signals from this event have not reached us, cannot be accessed by us, is it true that if it happened only 3 years ago, it's irrelevant to us? Let's say that Andromeda evaporated into nothing 1 million years ago. It will be almost 2 million years before this information becomes available to us here on Earth. Supposedly, whether or not Andromeda exists now at all can have no bearing on our knowledge and understanding. It concerns occurrences at a very great distance that make no contribution to our experience, and specifically to the experience from which we derive our understanding of reality and of time. But is that the case? Is it really of no consequence now here on Earth whether or not Andromeda exists? At the very minimum, just the thought that it doesn't exist would require revolutionizing the cosmological theories from which our knowledge and understanding of galaxies is derived. So just this thought experiment, I think, shows that we're not indifferent to what's happening now on Andromeda. I want to give another parallel here. You're all familiar with Russell's conjecture that the universe was created 5 minutes ago. He brings it up, I think, in the analysis of mind and dismisses it immediately as uninteresting. Wittgenstein thought it is very interesting and devotes an extensive discussion to this conjecture in his Uncertainty, where he concludes, and this again has to be elaborated, that the understanding that the world was not created 5 minutes ago is presupposed by our very ability to talk. And if we begin to challenge such hypotheses, then the notion of knowledge begins to fade away, to dissolve, which is in a way a self-refuting move, of course. Because if we raise a hypothesis, the consideration of which undermines the language with which we raise it, then we've just defeated ourselves. And I want to argue that the supposition that the time doesn't flow on Andromeda, or the tense doesn't apply to Andromeda, and so on, is of the same class of hypotheses as the hypothesis that the world was created 5 minutes ago. So it belongs to a background which is presupposed by our very ability to do science, philosophy, and so on. So I want to finish just with a conclusion. When it comes to time, the cosmic and the conscious are inseparable. Time as we know it from our first-hand experience, time as it figures in our sensing pain or in our enjoying fireworks in the sky, figures in our dealings with Andromeda. That conscious time ticks on Andromeda just as it does when we listen to our own heartbeats. It's part of the background against which science, against which anything else we may want to say about Andromeda becomes even thinkable. And conversely, Andromeda, the rest of the universe, the stars near us, are part of the world within which conscious time operates. Like the past that is very distant and outside our experiential reach, like the past, what is very distant and outside our experiential reach is nevertheless important to our understanding of the world and of our place in it. The global present is part of the conditions that operate in our local experiencing. Conscious time, tense as it figures in our experience, hangs in a void without a global present within which it is embedded. Cosmological time is as non-existent as sound is to the deaf without conscious tense time that renders it accessible. Okay, I had some further ruminations, but I'll stop here.
Flat Earth argument. I'll try to explain from the flat Earth argument. I walk around this globe. My feet believe that the Earth is flat, and my access to the roundness of the universe is through the fact that I'm locally in a flat universe. Now, I think that's an important point because it may be that all, not just conscious time, but all of lived time of all living beings, phenomenologically, is as you describe it, without necessarily saying anything about the time of non-animate bodies. Because you could say that animate bodies are anti-entropic, therefore they have a conception of time which is purposive, directed, all kinds of things, and therefore they need tense, because they need purpose. But if you think of stones falling in the universe, they obviously don't need any such thing. And so to say that you need to access the universe through your own phenomenological time is obviously true. Just as I have access to the roundness of the universe, the roundness of the Earth through my flat feet. And it doesn't help me if I think I'm walking on a ball at all. But that doesn't, but to say that my flat feet are part of, that my phenomenology of the flatness of the universe is part of, the flatness of the Earth is part of the roundness of the Earth, I don't know if that works.
Okay, I'll answer very briefly. The argument I was trying to use your analogy. Okay, so I'll revert to this fable. Either the Earth is round or else it's flat.
Right.
Now, I think I gave an argument that it cannot be flat.
I gave the argument that it is flat because we access it as flat. It is non-existent sound to the depth without conscious test time that renders it accessible. I access the world through whatever I have, but it may be that my access to the world is relevant to my local needs or position or whatever else, and that I agree with you that Dieks' argument the opposite way also doesn't work because he thinks that my personal experience is explainable physically, which is just as wrong.
Yeah, no, the fable is a bit misleading because the Earth is locally flat.
Yeah.
It is indeed mathematically, geometrically flat locally, as Dieks just explained. Locally, the geometry of any surface is Euclidean, even if globally the surface is not Euclidean. But what I'm saying is that the present, so now going back to our subject, the present is either local, by which I mean it doesn't exist because I can't accept a present that is, of a radius 5 centimeters, of radius 300,000 kilometers or whatever. It's either a vanishing point of zero volume, which for me is nothing. So there's not one event in my brain, assuming it takes more than zero volume, that is present, or else it's global. And I think I've shown that if you get rid of, and I think that's why Dennis's thesis is very exciting. When he says simultaneity doesn't figure in experience, that's a very interesting claim to make. Now, if I manage to undercut that, I think I get not only local simultaneity, you say it for me, but you get global simultaneity.
Do you think that denies
I
relativity?
think we should let Dennis say something.
No. Actually, I couldn't follow your argument why we need the global now extended now to make sense of our visual experience. You said that our visual experience disintegrates without any notion of an extended now, but at the same time you admit that this now doesn't play any role in our experience or our visual experience. So what's the argument here?
No, the second part of what you're saying is a misunderstanding of what I said. I think now plays a huge role in our experience, a huge role. I think only what happens now can be experienced. And I think this statement cannot be...
That's a global now, not a global.
That's true. That's a global now. It's true. Any experience that we may have has to be present, whether the experience is local or global. It doesn't matter. But with respect to your first point, okay, you want me to...
Well, experience are always global. Here.
No, I don't think that when I'm looking...
That of experience can pertain to other places.
Okay, so I mean, you're relying on, I think, a highly controversial and contestable theory of perception, according to which perception happens, and you shouldn't do here, because, the brain is a big world, and it contains billions of elements, and, I don't know, when you point to this, you're pointing very, very indecisively to where experience happens. So I don't think that if we're moving for a second to the philosophy of perception, that there's a viable theory of perception according to which experience happens here. I don't think there's any good account of that. And therefore, I do think that experience, visual experience, for example, me seeing this room, involves many elements that are simultaneous. They must be simultaneous. If I said this is a long discussion in the philosophy of perception, but if I'm seeing you, that is in virtue of the fact that there's a visual field before me. It has a structure, and this structure, in describing this structure, I will have to revert to the notion of simultaneity. I won't have the visual field without it.
Just to add something to the whole debate here, I think that there is, I just wanted to make the point which I raised actually yesterday, and I think it is relevant, and because, well, maybe I'm mistaken, but it seems to me important, and then to provoke you to something. And that's related to the point-likeness of our experience. I mean, I said it yesterday, and I think it is true, and anybody who talks about the specious present and the duration of time, the minimal durations of time which our brain processes require in order to have a perception and stuff like that, still all these things, in order for these statements to be compatible with physics, physics tells us that everything that's happening in the universe is point-like. That's a fact. I mean, this is what physics says. So, I mean, if you want to Now the task is to explain everything we wish to explain. If we learn in neurophysiology or something that brain processes which are involved in perception take time, we need to make our way so as to make this compatible with what physics tells us, that when I have a perception, my brain state, the micro state of my brain is point-like. That's what physics says. So we have to deal with that. And this has come, I think, to pass here too quickly, and I think that you should think about it. Now the second thing, which is related to more directly to what you said, Dennis and Yuval, is that there is something really surprising in both of your approaches, because as Dennis just now pressed you, there doesn't seem to be anything global in the present, as in the way that, I mean, the globalness here doesn't seem to do any work, unless there is some conceptual thing that goes on which was not clear, but, I mean, so I would just change your title to local now and everything would be fine. The other thing, on the other hand, and this is more to Dennis, I mean, I always took your paper about your point about the inefficacy, the causal inefficacy of distant events and simultaneity and stuff like that to be meant as, in support of even something like Stein's theory, Stein's ideas about a point like present or something like that, and so that it takes you more into the direction of the A theory rather than the B theory. So that's just so I think that, I mean, you could agree, but you have to...
Okay, so I'd like to
Go on.
I'd like to respond to it. First of all, our workshop, of which May was an important member even when he was absent, tried to bring together cosmological, psychological, various perspectives on time, and I think we need this kind of integrative approach, because if we limit ourselves to one approach at a time, we just lose it. We don't get very far with our analysis, and I would say that this point-likedness that you were highlighting, I'm a bit sorry that David Wood isn't here. He's now burying something near the Dead Sea, which I warned him, because of global climate changes, will probably be exposed next week, because there are these abolanim. He's burying. I hope he himself is not there. But he and even more so Eli yesterday tried to make the point that we have no present without a past. And I think this phenomenological point that descriptions of anything presuppose a history is very important, because I think, and this is I think the part you won't like, I think there's no science without this kind of phenomenology. So I think phenomenology precedes science. The notion of point-like events is an idealization that we create in the process of doing science. But the process of doing science presupposes something which cannot accommodate this idealization. So that's with respect to your first point. I reject the notion of point-like events. I just don't understand. I don't think we have such a notion. We have a mathematical idealization. That's the first thing. As to your second point, remind me just quickly.
Well, the globalness.
Yeah. Well, so look, if there was a viable notion of a local present, I would be happy with it. But I think it just makes no sense to think of a sense of a present, a real present. If we're talking about a fable, in my mind, we can do there whatever we want. But if we're talking about a real present that stretches from here to the moon, so
what do you mean a real present? A phenomenal present?
Not a phenomenal. No. I want to talk about a real present, as real as the moon is. So it makes no sense to me that one half of the moon will be within this present. We'll be able to ask what's happening now on one half of the moon, and then we move a meter away, and the question stops to make sense. So I cannot accept a spatially restricted present. Therefore, I have to choose either B theory or global present. And once I've been pushed in a way into accepting a global present, I want to ask what the meaning of this global present is, and that's what I tried to do in the last part of the talk, which I was rushed through, so I didn't get very far. But I think that for us, the ability to think about what's happening now at any location in the universe is kind of the precondition of our ability to experience things locally as well. But this needs to be elaborated a lot more.
Two small comments. Neither very philosophical, but you might find it interesting anyway. First, about the cosmological now. Most astrophysicists, as opposed to other kinds of physicists, would now say that there is a cosmological now. Cosmological theory, you know, that as may remind us, simultaneously is frame dependent. And there is a preferred frame of reference, cosmologically speaking, that's the one in which the background cosmic radiation is isotropic. It's the unique frame of reference in which that exists. So there is that simultaneous frame of reference which seems to be preferred to others, but it's not ours. We don't live in that frame of reference, so whatever we experience is not that global simultaneously. Second, about this discussion regarding to the point-likeness of things. I'm not sure exactly what to make of it, but there is in relativity theory a concept that makes this is very important and that shouldn't be thrown away. It's true, I think, like Dennis, that simultaneity of distant event plays no role in physical explanation of specific phenomena. But coincidence makes a lot of sense. So it's very important when two things happen at the same time.
At the same place.
Point. Okay. At the same point. And so it's not entirely true that if you don't have a now that is global, you don't have a now at all. You might have a completely point-like now and still have something that makes sense in relativity. So that might be another sort of door that you might want to explore.
Okay.
One final question.
Yes, thank you. You propose to replace the ontological with the phenomenological, and I'd be happy if you could say something more about this. In particular, do you think is your proposal restricted to time, or is it a general proposal? And and also, what are the relations then between the ontological and the phenomenological? Do you mean reduction? Do you mean that the ontological is nothing but the phenomenological, or do you mean that there's a separate project, or what are the relations between the two realms?
Okay, it's a big programmatic kind of questions. So of course it's not just about time, though. You know, I wouldn't be able to say much about domains in philosophy I'm not familiar with enough. If I have to put these in order, then yes, I'd say the ontological investigation follows the phenomenological one. But you know, there are people here in this room whose careers are built on this kind of phenomenology. So you should probably ask them. But yeah, the notion that we have, what I've always felt abhorrence towards is the notion that we have some kind of access to ontology that is not phenomenological in an important sense, that there's some kind of pure access to what there is and what there isn't, which is not completely structured phenomenologically, which is not to say, that's what interests me, is not to say that you have to be an idealist or an anti-realist or something like that. I think the interesting versions of realism are those that take into account that our access to the world is our access to the world. It is still the world. It's not the world we make. It's not a world constituted by us. We don't decide whether propositions are true or false, so you know you have bivalence and all that. But the world that we access is accessed by us, given all the contingencies that go into who we are.
Okay, well, thank you very much. Very good.